Okay, hello everyone. So today I'm going to be showing a video of how to calculate the maximum range of a projectile. And of course, I'm going to do this through the game of Minecraft. Okay, so in order to do this in Minecraft, the first thing we have to do is, okay, how fast exactly does my arrow fire in Minecraft? And I think the best way to do that would be to fire horizontally. Because if I fire horizontally, I can just simply assume that the angle is equal to 0. I can then compute perfectly horizontal, and that will mean that my velocity will be at the horizontal. Once I get that velocity, I'm simply going to aim the arrow at the maximum range angle and fire and see if my calculations match the game. So I'm going to go at a height of 10 meters above the ground, like so, and I'm going to use the tool F3 in order to get my angle, because as you can see here, it says they're facing west towards negative x, and actually the second number there, 0.5, that's the angle that my cursor is pointing, because if I go down, it says I'm 14.1 degrees. If I go up, I'm 20 degrees. So let's see if I can get it as close to 0 as possible. It's not an easy thing to do. I nearly got it there. You know what, 1 degrees? I think that's fine. Okay, let's fire again. Let's have 3 trials. Okay, so there's a bit of a slight error there, but it's around 1 degrees. So as you could see, it landed between 50 and 60. Now my instrument is not very precise, so I'm just going to assume it's 55 meters. So there's a bit of an estimated digit over there. And I know that I fired it from a height of 10, however I was standing, so let's just say that my height was 11 meters above the ground. So let me just quickly escape the Minecraft world for a sec and go into my paint so I can get my calculations going. Okay, so let's see my observations. Based on my experiment, I fired an arrow like this from a height of 11 meters above the ground, and it landed around 55 meters away from me. Okay, so in any problem like this, the first step would be to solve for the time of flight. Okay, so the time of flight, we already have run through the formulas before, and the simplest formula for this is 2 delta y over a y. Okay, and we know that it fell 11 meters, so that's negative 11 all over ay, which is negative 9.8 meter per second squared. And if we were to get my calculator out, so that's going to be equal to square root of 2 times negative 11 all over negative 9.8 gives me a value of 1.49 seconds. Okay, 1.498. Let's preserve as much decimal places as possible to be as accurate as possible with my computation. So 1.498 seconds. Now that we have the time, we can then say, okay, what's the VI of the arrow? And in order to do this, we can use the formula VIT plus 1 half AT squared. But we know that in any projectile, the only acceleration that you're dealing with is gravity. So any acceleration in the x is 0. So we can then rearrange this equation to just isolate VI delta x over t. Okay, we know that it went around 55 meters away, and we know that the time of flight is around 1.498 seconds. So if we were to get 55 divided by that, so that's 55 divided by that gives me around 36.7 meters per second. Okay, so my VI is around 36.7 meters per second. So now that we have the VI, we can then say, okay, how then do we get the maximum range of an arrow in Minecraft? So we know that it flies this way, but what's the angle? Well, if you remember the video before, the optimum angle at which to fire any projectile is around 45 degrees, because this is a perfect balance between having a good horizontal velocity and having a good time of flight, and that can only be achieved in 45-degree angles. So let's see. The first step in any angled projectile problem is always to get the components of velocity. Okay, and we can say that the components Vix and Viy will be equal to cosine and sine respectively. So VI cosine theta, VI sine of theta. However, we know that for 45-degree angles, okay, if this is 45 degrees, VIX would simply be equal to VIY because you are perfectly in the middle of 0 and 90. So VIX is equal to VIY. And we can make this generalization in order to just simply calculate only one of them rather than both. So we know that these are equal. So let's just use cosine, VI cosine theta. And we know that it's going to be 36.7 meter per second, cosine of 45-degree angles. And if we get our calculator out, that one cosine, oops. So answer oops. Why am I, where's my calculator going crazy a bit? Again, answer cosine of 45, don't go crazy, equals, there we go, 25.95, so around 25.96. Let's preserve as much decimal places as possible. So that's 25.95, what's that, 9566947, around 25.95, so it's 25.96 meter per second. Okay, so that's the x and y component of velocity. This is VIX, which is also VIY. So now that we have this, we can then compute, okay, how long does it take for the arrow to reach the target, time of flight? And we can do this by looking at the case of free fall, that it goes upward and then back down again. So it's very similar to this, except that it has an x velocity. And we can analyze this using just the y and make some generalizations, such as, you know that the angle of launch, VIY, is simply equal to the negative of VFY. So the initial velocity equals the final velocity because they land at the same spot, at the same height. Okay? So, time of flight, we know that VFY is equal to negative VIY. Let's use the first equation, just the simplest one. VFY is equal to VIY plus AT, but with the knowledge that this is going to be equal to negative VIY. So let's rearrange that. Negative VIY is equal to VIY plus AYT, this is AY, and AY again is negative G. Okay, so let's rearrange this to go to negative 2VIY over G, gives me the time of flight. But that's negative because this is negative after all. Negative over negative simply gives me positive. Okay, so I can use this formula to then just get time. That will be equal to, 2 times the VIY. What's VIY? VIY we determined to be 25.96 meters per second and 9.8 at the very bottom because of G. So let's get the fraction out. 2 times that answer previously divided by 9.8 gives me a value of around 5.29 seconds. Okay, let's say 5.30 seconds. So this is your time of flight. Now that you have the time of flight, we can then determine, okay, what is now my range, which is delta x. Now, I think the simplest formula for this is delta x is equal to VIT plus 1/2 AT squared, but with the knowledge that any acceleration in the x is negligible. So, it's just simply VIXT. Okay, so VIXT, we know that VIX is also 25.96, and we multiply that to the time we just solved, 5.30 seconds. So let's get the calculator out again. Whoops, what's happening? Whoops, answer times 25.96 gives me 137.5. Okay, so that's delta x is equal to around 137.5 meters. Now, it's all well and good to calculate this through theoretical means, But what about actually proving it in the game? Okay, so let me get my Minecraft out again. There we go. Now let's actually prove it. So to do this, let's stand at my start point, but in order to really get the angles right, let's go down 1 meter so that we're almost at ground level. Okay, let's try to get a 45-degree angle and get 3 shots in and see where it lands. 3, 4, and 5. 45 point. Okay, this is good enough. Whoops. I think that's better. 1, 2, and 3. Okay, so where did that land? Let's see. Okay, so there they are. So it landed around 110 to 120 blocks away. So if we compare this to our actual values, okay, so let's get our actual values out. So we landed at around, let's say 115 meters away. So there's a bit of an error involved, and I think there are some factors to this. First of all, it's not really, I don't think it's really 1 meter above the ground or above the firing line. So it's not just 10 meters plus 1. I think it's 10 meters plus 1.5, so that's one factor. There are other factors. This is an average after all. And I think Minecraft has a way of randomizing arrow flight so that it's a bit inconsistent, and it accounts for the fact that it's not really something that human error means that it won't fire consistently. But nonetheless, I think you can see that our calculations landed at a relatively close value of 115 or 137.5 versus the actual value of, excuse me, so this is the theoretical. This is the actual. So it's pretty close. So anyway, I hope this gave you an insight as to how to calculate the range of a projectile launched at an angle. And it's a step-by-step process. The first step to get the components of the vector. Second step to get the time of flight. And the third step to then get the range or whatever it is that you have to solve. So that's it. Thank you very much for watching, and I hope to teach this to you in the next days to come. Take care.